Hello students, we continue our discussion on friction. If you remember, in our lecture class we already seen the concept of friction and few examples. So let me first revise these equations, different equations that we are using in this friction. So if you remember, that first equation is F max is equal to nu s into n. F max is equal to nu s into n. This is one very important friction equation we have seen. In this equation, this nu s is the proportionality constant called the coefficient of static friction, and n is the normal reaction. So while discussing that concept of friction, we have seen that the friction force is proportional to the normal force, and we can remove that proportionality using this coefficient of static friction or coefficient of friction. This equation describes only the limiting or maximum value of the static friction force and not any lesser value. This equation is applicable only when motion is impending, that is, motion is just about to start. It means here the friction force is at its peak value, okay, and when motion is not impending, the static friction force is less than nu s into n. So just understand these two equations. This equation equal to sign you have to use when the motion is impending, and here the value of the friction force is less than. Now we also seen this equation, Fk is equal to nu k into n. This Fk is kinetic friction. So when slippage occurs, when any body object is start moving, that kinetic friction come into the picture, and in that case we use this equation nu k into n. It is this value is less than the maximum static friction force, so we use it nu k is equal to n. And we have also seen this one equation, tan phi is equal to nu, okay, where phi is angle of friction. So this is just revision of few equations, and let's take some example.